Get us started. Welcome everyone to Learning Through Stormwater, how schools can use GSI for flood mitigation and education. My name is Sarah Coles and I'm the Executive Director of Texas Children in Nature Network. We're excited to have you with us today. We are recording our session today. Thank you so much for joining us. Please mute yourselves and turn off your cameras for the presentation to save for our bandwidth for our attendees, and for a clean recording. If you have questions during the presentation, you can put them in the chat. Let's see here. Oh, I lost my post-it. Here we go. Okay. Melody is running tech for us today. Thank you so much, Melody. As I said, we are recording. We'll share it in a follow-up email. If you're uncomfortable with your name showing, you can change your name to anonymous and then private message Melody with your name for our attendance. If your Zoom name doesn't match the name you registered with, please change your name or let Melody know. If you are in need of a certificate and we don't have your name, we will not be able to provide a certificate. And just a reminder, if you are needing that certificate, just follow the directions in the email that had this Zoom link. I'm going to go ahead and do our land acknowledgement. Texas Children in Nature Network is headquartered in Austin, and as such is in the ancestral and unceded land of the Tonkawa, Comanche, and Sauna people. Our ongoing colonial presence on indigenous lands compels us to take action now to counteract the effects of colonization. The work we do through the Texas Children in Nature Network is one small step towards that effort. In just a minute, I'm going to put some links about land acknowledgements and those people groups in the chat. And now I'd like to go ahead and welcome our speakers today. Lauren Maples is with PEAS, and Staryn Wagner is with Austin Watershed Protection. Thank you so much for joining us today, and take it away.
Hello. Thanks for coming out here. And let me, Lauren, do you want to do any introduction, or shall I just hop in and you're
Here,
muted? Yeah.
I just thought we could just give them an overview of our agenda. Is that you'll be talking about the infrastructure piece, and I'll talk more about student engagement after Staryn shares all the ins and outs of what is in place and how it is working for the school and community.
Excellent. Thank you, Lauren. Right. So my name is Staryn Wagner, and what I'm going to be going over is mostly what we did at Reilly Elementary School, which is a school here in Austin. Give me a moment to try and get back to where I was.
Looks good on our end.
Okay. There we go. I unfortunately expanded everybody's pictures, and now I'm back to it. Okay, so I'm going to be going through essentially the Reilly Green Stormwater Infrastructure design, construction, maintenance, but I also wanted, not knowing like what all everybody's background is, I thought what I would probably do is just go ahead and start at the very top of the idea of why we even have green stormwater infrastructure. And that's essentially the journey of the raindrop. I thought it'd be nice to find out who everybody was, but I think that might get a little confusing, especially for me trying to manage this right now. So while I would love to know who you all are and what you want out of this, feel free to throw questions into the chat. And if you have just something really burning at you, just hop in and interrupt me. I can always pick back up after we cover something. So the journey of the raindrop is, really where all of this begins. It's the hydrology of this. As that raindrop falls from the sky, what happens to it, especially in like how it used to. Hang on, something popped up here. As it would come down from the sky in a natural environment, and then hit trees and the leaves on the trees, which would slow down that raindrop. And then with less impact, it would hit the bushes underneath and the grasses underneath and slowly drip down and follow the root channels and the interstitial spaces in the soil and make its way down into the ground where some of it would evaporate back up into the atmosphere. There'd be plant uptake. The water would also travel through the soil, finding its pathway to the streams. That's where our streams come from and why streams flow when it's not raining. But then we have a situation where we start building things out. And in this scenario here, I only show two examples. One of like the fully native natural forest and heavily urbanized area, right? And you can see that we, there's some stuff here. You can see that we got a drastic change in the water balance, right? There was like 40% evaporation before and 40% evaporation before, 30% now. But the big difference is that if you look down what's going on the ground there used to be like 50% of the water going into the soil, both to deep infiltration and to the shallow infiltration. But in this urbanized setting, it's now down to 15. So a bulk of that is now runoff, right? So when it rains, instead of so much of that water seeping down into the soil, it's just running over the surface and going to the stream immediately, right? And so that gets us to a stream, right? A stream is really just rain, geology, and water flow, right? And you get these streams that have riffles, runs, and pools. And that's how all of our natural streams developed. And they had, a lot of them just a very nice sort of scalloped channel. But as we divert all this increased runoff in these suburban and urban environments to the stream, we get what's known as the urban stream syndrome, right? So our stormwater is going into these pipes, and these pipes are just shooting them out like water cannons at our creeks. And our creeks are down cutting. So now instead of just like a nice sort of shallow scallop, which is the profile of the stream, we have these steep, deep channels that are just down cut, usually to bedrock in this area. And that's, created a lot of erosion and causes a lot of other problems. And so what our traditional system or what our common system is the gray stormwater system, right? So you can see that raindrop lands on the rooftop, runs down the roof into a gutter, goes down the storm or down the downpipe, which usually gets diverted to the driveway. It goes down the driveway into the street, down the street gutter into the storm inlet. And then it all collects, all of these different sources collect in these storm sewers, and that outlet just blasts it out to the creek. That's been very effective at getting rid of our stormwater, and that was the focus. But what we've realized is we're starting to really starve our earth or our soils of groundwater, and we've caused all these problems within our creeks, because now diverting all of that water so immediately to a creek, that raindrop originally could have taken days, weeks, months, years for it to travel from the sky to the creek. Now, with this gray stormwater system, that raindrop and all its buddies are delivered to the creek within like an hour, right? So it is just this massive inundation of water, and so it causes a lot of flooding as well as erosion, and blasts out our aquatic habitat. So the green stormwater idea is to change that hydrologic process so that we intercept that raindrop once again, and this time try and slow it down on its journey to the creek and get it back to that infiltration into the soil. So, what are some of the benefits? Why would we want to do this? Well, for one, whether it's running off of your house or off of a street or parking lot, or even just surface flow over like your front yard or a park, there'll be a lot of pollutant treatment, right? So if we can get that water to stop and sink into the soil, then the biota within the soil has the opportunity to break down pollutants and control contaminants, and sometimes just hold the contaminants, right? Some things take so long to break down that we won't see that anytime soon, but we're keeping it out of our waterways. Also, we get the infiltration into the soil, where we then have the benefits of groundwater recharge, more water going to the streams during drier times, and keeping our plants alive, our grasses, our trees, our shrubs. And in this runoff, or in this interception and infiltration, we get a runoff reduction, right? So that water cannon that I keep talking about blasting into the stream, there will still be some going to that, but we've reduced it. And so the two types of green stormwater infrastructure methods that I'm going to talk about, one is the rain garden. We've talked about some of the function of it, right? There's several types. There's a variety of components to a rain garden. There's different vegetation, maintenance design. So these are all some things that I'm going to cover. Functions of the rain garden is capture and divert runoff, right? So normally, like I said, all of this water is most frequently diverted to the street. Our streets are made to collect rainwater. They have a high point in the center, and the outer edges by the curb are down low. So that's why it's called curb and gutter. Those are sort of the gutters of the street. The center is high so that even when there's a lot of water in the street, the emergency vehicles still have sort of a shallower or drier part in the center that they can move on. We're looking to intercept that before it gets to the street and create, like in this left picture, a rain garden, which is at the very front of Reilly Elementary School. Normally it just looks kind of like a garden, but we made some small changes to it. It's where the runoff used to go anyway. And now it holds about 8 inches of rain every time it rains. And the other function is to slow this water down and infiltrate it. So if we can get water flowing through a vegetated area, even if that rain garden is full, the vegetation is going to slow down the movement of water. So we're at least giving it a little more time to soak into the ground, and we're not rushing it to the stream or to the storm drains as quickly. So there's a couple types of rain gardens. And we could probably go into more detail of different types, but two key types that I like to point out are an inline rain garden and an offline rain garden. Now, the inline rain garden has an inlet for water and a separate outlet for water. And so as soon as the rain starts and runoff begins from your drainage area, the pond starts filling up because the water's flowing in from the inlet. But once that pond fills up, then the water that's flowing in passes through the rain garden and it goes out of the outlet, right? So the pond is full, the water needs to keep going somewhere, and all this water passes straight through the rain garden, out the outlet, and onto whatever pathway we've chosen for it to go afterwards. Now, an offline rain garden, which is the kind I tend to prefer, it has only one inlet, no outlet. And so it's set up such that as the water is flowing off of your drainage area, it flows into the inlet. And then once the rain garden fills up, the water just then naturally bypasses the inlet and carries on in the direction that it was going anyway. And this is nice because you can, one, set up a rain garden just on the edge of an existing flow path for your rainwater, but also because that first flush of runoff is usually what carries the majority of the pollutants, or at least the most concentrated form of pollutants. And so in this offline one, that pond, that rain garden fills up with that heavily polluted rainwater. And then all of the cleaner rainwater bypasses it. With an inline rain garden, depending on how it's set up, but most frequently, the water coming in, it first fills up once again with that first highly contaminated amount of water. And then the rest of the clean water kind of passes through, washing out that more polluted stuff. So it doesn't do as good a job as like grabbing and holding onto those pollutants because some of them get washed out. Components of a rain garden, we've kind of talked about this, inlet and outlet. So you have to set up somewhere for the water to come in, and you have to either set that inlet up so that once the rain garden is full, the water bypasses, or you have to set up also an outlet so that when the rain garden is full, the water flows out of it without eroding any of your berms or the outlet itself. So it's important to harden that. If you have water flowing in fast, then what you need to do is set up some sort of energy dissipator. And in this picture, I have just some big rough rock that is too big for the velocity of the water moving into the pond to move. And so it takes a lot of the energy out of that water and slows it down. And then berms. Berms are what create the sort of dams of your rain garden. And when you're excavating a rain garden, like digging the hole for it, it's nice to have like thought this whole process out so that the soil you're digging up, you're using as your berm. And the berm itself also should be about 4 to 6 inches higher than your outlet. So you don't want it to be at the same level because it's hard to get everything perfectly even. And if the water finds its way over a berm, which is usually made of soil, the soil will erode a lot easier than a hardened outlet. So if you make your berms about 4 to 6 inches higher, the water will be flowing out of the outlet before it ever even considers trying to get over a berm.
Staryn, we have a question real quick.
Yes.
In the chat, it says, is there a cost difference as it relates to the design and maintenance with the inline and offline versions?
Yes, I would say there is somewhat of one because you do have to construct a hardened outlet. And when I say hardened, I mean anywhere from like brick, flagstone rock to concrete, right? So if you just have an offline one, you're only constructing one thing for, one passage, and that also needs to be hardened for the water to flow in. But if you have the inline, you also then have to build one for the water to flow out of and not erode your rain garden.
Well, speaking of erosion, we have another question.
Yes.
How do you make sure that you're not undermining infrastructure with rain gardens or depressions? Is there a distance that is needed to be away from sidewalks, roads, or buildings?
Yes, and I do mention that a little later, but good question. It's there is like it's hard to say that there's a definitive distance. Like different buildings have different foundational situations, and it's always something that in the placement of your rain garden, you really need to kind of look at and think about the fact that, okay, I'm going to be putting water into this soil. And so it'll be a lot wetter. And if you look at this, like in this rain garden vegetation slide that I have up, I've got this one with the sod. And you can see we're probably a good, I don't know, 8 feet from the building on that. And we wanted to keep it like the general rule is 5 feet away from a building. I've seen plenty of rain gardens that are closer than that and have caused no problems whatsoever. But, if you have the space, then it's good to get about 5 feet away from a building or other sort of hardened infrastructure. versus like this rain garden that you see in the left picture under the fully vegetated um, uh, title. That is like right on the edge of a parking lot, again at Reilly. Both of these are at Reilly Elementary School. Um, Such that, however, there is a nice slope that comes down from that parking lot. So really, the water holding component of that rain garden in the fully vegetated picture is about 3 feet horizontal from the parking lot, and then about 18 inches down, like 18-inch drop in elevation from it. So it's still a nice distance away from it. Um, and there have been no problems whatsoever with at that parking lot with this rain garden, and this rain garden has been there since I think 2018. So it's, you know, it's weathered in. Are there any more questions? I don't see the
That's all for now.
chat.
Yeah. And if you'll do the same with me when I'm, because yeah, you can't see it when you're presenting right now. I'll
Yeah,
grab you if any more pop in.
thank you, Lauren. Okay, so the rain garden vegetation. As you can see in these two pictures, we've got like the wild and woolly one over here on the left, the fully vegetated, and that one we just went nuts. You know, we had permission in this area to not worry about nice and manicured. It's at the not exactly the back end, but it's sort of at the maintenance access side of the school and blocked by a parking lot. And I mean, I love this. This, you know, that's what I'm after, but not every location or every person wants that aesthetic. And this one on the right, which is pure sod, it's all Celebration Bermuda is what we lined the rain garden with. You know, it's collecting all this runoff off the parking lot. It goes in there, infiltrates, and if the soils aren't muddy, then they just mow it like all the rest of the grounds there. You know, and it just, most of the time, it just looks like a big part of the yard. It's a little bit depressed. I think it's only like 8 to 10 inches deep to hold the water. And so the maintenance changed not at all for the grounds maintenance crew on that one. And on the fully vegetated one, they don't do anything but trim the edges, right? So they don't even have to worry about that one. And so long as that aesthetic is acceptable in that location, it just gets to do whatever it wants to do. You know, we don't really care what plants are in there. So it's, you know, what it looks like is all up to the aesthetic needs of the location and the people in charge of it. So now designing a rain garden. Let's go through some of the steps of that. First, look for like where do you put one and why do you put it there? Well, a good reason to put one somewhere is because there's some problem upflow, like from that location, or more like you look for a problem and try and put a rain garden either up from that or just down from that. It's nice when you have the opportunity to see a problem like in this left picture where you've got a lot of concentrated flow and erosion. And this is at the back side of Reilly Elementary, where like all of even the front parking lot that I showed you, that big sodded rain garden, it flows all the way around the back and joins with so much of the back overflow and rooftop runoff, and just created this channel that had down cut and eroded and was exposing roots of a really nice tree that has since died. So what we did was set up a lot of our stuff. Like I saw this as a major problem. And I'm like, okay, in order to impact that, I have to address almost all of the runoff from that is heading to this location, or as much of it as I possibly could. And of the 5 rain gardens and 11 cisterns that I put at Reilly, 8 of the cisterns capture water that's going to this exact spot, and 2 of the rain gardens. So we were able to considerably reduce the amount of water that was going to that, and that erosion that has now been filled in has not come back. And then in this other spot, we've got pooling area, right? So I saw a lot of water pooling in this spot, and it was like, okay, this might be a really good place to put a rain garden, right? We'll slope that a little more so we get the water to drain away from the building and into the rain garden. And that spot where you can see my boots standing in the water, if I recall correctly, is where that sod rain garden is. Um, right, so location, you know, we, in this particular case, chose Reilly Elementary School because we wanted to get the community to do more green stormwater infrastructure. And Reilly Elementary School has a combined interlocal agreement with Parks and Rec Department, or Austin Parks and Rec. And so when school's not in session, the school grounds are part of the park, and so the public has access to it. So if I did what I did at this location, they should be able to then go and take a look at it. Now, drainage area and flow path. So, let me go back for a moment. The other thing you want to look at here, and I think this slide, yeah, it didn't. I didn't quite get the one that I wanted. I can see that two are stacked and the wrong one's on top. But you look at unique drainage areas. And so I had all of this area separated up into like small drainage areas. Like I knew where the roof ran off to a gutter, and I had that drawn as a square. And so I was able to think of this whole area as unique drainage areas that I could then start to focus individual stormwater controls, green stormwater controls for each of those, and I would know how to size them. And right, so a drainage area here, an example, and this is from Aikens High School, is you can open up Google Maps, and if you right click, you have an opportunity to draw things, and you can draw areas, and it will tell you the square footage of that area, right? And so when you do some design stuff, it's important to know how much area you're collecting from, and then you'll also need to look at like how much area you want to use for a rain garden. And those are going to be factors that you consider when you are doing your calculations. Like, you want, so all of the rain gardens and cisterns that are designed at Reilly Elementary School were designed to capture roughly 1.3 inches of rainfall on their drainage area, right? And so I picked 1.3 inches because 90% of the storms that we get in Austin are 1.3 inches or less, right? So all of the things that I set up and designed there were set up to capture 90% of the rain that's going to run off from that area. And that's a considerable amount of interception of rain. And so anyway, you do some calculations, and I included a PDF of this presentation in the chat, so you can not try and remember all of this as I'm spewing it out, but you can go ahead and just like reopen that up and look at how I did things. But so you can do some calculations to figure out how much is going to run off of your drainage area. And then you're going to use that to, in combination with the infiltration rate, to determine how big your rain garden needs to be. So when you do a rain garden, it's not exactly a one depth fits all. It's important to, not absolutely necessary, but it's important for a successful, or to help guarantee the success of your rain garden, to understand what infiltration rate that specific soil has. And a simple way to do that is you just dig a little 12-inch hole, fill it up with water, let it soak in. And if it just soaks in real quick as you're doing it during a really dry time, fill it up a few times until it starts soaking in slower. And then you fill it up. Once it's slowed down, you fill it up, and every like 15 minutes, you mark the time and the depth of the water, right? And then you take the last few of those because you're looking for a constant infiltration rate. And you just average them out so that you come up with an inches per hour, um, an inches per hour rate, and that is your infiltration rate, right? And then that gets used in our next step, where we know like the infiltration rate, right? So we've now got, with that drainage area, we're going to, and with the drainage area and the infiltration rate, we're going to determine how deep our rain garden can be. And that's essentially, the area of the rain garden times the depth equals the volume. So if the volume of my drainage area is 585 cubic feet, which is how much, how big the area I had drawn in this previous picture, real quick. This picture here, which was 5,401 square feet. And I multiplied that times the 1.3 inches of rain, which I think I converted the inches into feet because I have to do square feet times another foot measurement to get cubic feet. So I do 1.3 divided by 12. That gives me feet of rain. And then multiplied that out. And then the depth is going to be that rate, which is our 0.25 inches per hour times 48 hours. And so that's going to, and we do 48 hours. Oh, that's the other thing, right? You want a little bit of a factor of safety on this. That infiltration hole you dug, it's, it is a horseshoes and hand grenades type thing, right? It's close to it. It's not going to be the exact infiltration rate. And what we don't want to do is create a rain garden that just ends up being a pond and holds water for like 48, for more than 48 hours, right? Because then we have the potential of it breeding mosquitoes. So we take our infiltration rate that we calculated and then we cut it in half. So whereas it might have, like our calculation showed it drained half an inch per hour, let's cut that in half and just say it's 0.25 inches per hour. Then we can multiply that by 48. And what we get in this case is 12 inches. We can have a rain garden that's 12 inches deep. And, regardless of how much water is coming into it, like how big an area we make, if our depth is only 12 inches, if our infiltration rate is correct, all of that should drain down within 48 hours. It technically should drain down in 24, but sometimes you get one rain on top of the other, and so it just keeps coming in. Anyway, that's how you figure out depth of your rain garden, is your infiltration rate times 48 hours. And never do you want to go deeper than 12 inches, or at least that's the city's policy. We don't go deeper than 12 inches for safety reasons, and that's just sort of a safety element we've built into all our rain gardens so that we don't get ourselves into a bigger problem, especially when we start to have rain gardens all over the place. And then the design of your inlet and outlet. Like I said, it needs to be hardened. In the left here, I just have a drawing of two stone blocks and another stone block in between the two, so that the water can flow out in between those two parallel stone blocks. In the right picture, the armored inlet was quite simply just a bunch of cobble. right? So that it flowed over that and the water slowed down coming out of the downspout before it hit soil. Another example, I'm going to go back a couple pictures here, is in this fully vegetated one. You can see there I've got concrete and I have a metal grate that the water flowing down drops into that grate and then flows into the rain garden. Another example of an inlet. Okay, so now your vegetation decisions, we discussed that a little bit, right? You can go fully wild and woolly all the way to just plain grass. And those are decisions that you need to make. It's about what you want. We tend to think that larger vegetation helps improve the infiltration rate. At the moment, I'm working on a study of that over 12 biofiltration ponds here in town. Unfortunately, that study is going to take me about another 3 years to complete, so I don't really have any answers for you on it now. But the idea is taller vegetation has deeper roots, and those roots create channels for the water to flow down into the soil. Whereas mowed grass, sod tends to have shorter roots and doesn't help the water infiltrate quite as easily, but it still allows water to infiltrate. And you can divert your water into a vegetable garden or a landscaping garden, right? Constructing a rain garden. Here's an example of just a group of volunteers putting in a rain garden to capture a splash pad runoff over over by Mueller Airport. I can't think of the name of the park at the moment. So it can be as simple as this or as complex as getting a contract and having contractors build it with, machinery. They'll just go through. You want to, lay out where you're going to dig with string and lines, and you need something to make to understand what's level so that you can measure off that and make all of your depths correct. Dig your hole, use that soil to build your berms. Another thing is, as you're digging, there's a chance you're going to end up with extra soil. It's good to have figured out where you're going to put that before you start digging. That way you can just wheelbarrow it over to maybe some like depressions in a sports field or something that needed leveled out, or somewhere that there's been a lot of erosion that you want to build back up. And then you construct your inlets and outlets. And these are both ones that you can see from Reilly Elementary School. The interesting one, this one that's under the outlet title, that was back when Reilly Elementary was open to the outdoors. There's now a wall in between that rain garden and the classrooms. And then this one on the left, the one under the inlet title, is right at the very front of Reilly Elementary. And you can see that some of the sidewalk stormwater flows into it, and it gets water from downspouts and overflow from the cistern. And then once you've finished doing all your earthwork, the thing you want is soft soil there. And, especially if you've had big, heavy mechanical equipment doing all the earthwork, but even if you had volunteers, there's going to be a lot of compaction of the soil as you're rolling wheelbarrows in and out and people stomping on it. So it's good to come back in and fluff that soil back up before you put your plants in. And really all that's about, I'm not talking about turning the soil. I'm just talking about sort of getting like a spade shovel, or you can kind of see in this picture, Yaz has this like four-tonged fork that you jump on that, drive that into the ground, and then hang onto those two poles as you lean back, and it just like cracks the earth open and will then allow a lot more water to infiltrate in, and it helps it out quite a bit. And then you put your plants in, right? And it's usually the funnest part. But also you've got to keep them alive and help them get established while you're waiting on rain to come. Okay.
Star, I'm just going to give a
Yes.
quick time check. We've got about 20 minutes left, and Lauren's still got to do hers too.
Excellent. Okay. I will take 2 minutes to bust through this. I'm not going to go into the detail, obviously, on the cisterns. I just want to touch base on it then. Sorry, I talk a lot. And you've got the PDF of this, so you can look through this, but cisterns been around for a long time. You can use them either for stormwater mitigation or for water conservation. And a reason that you would do a cistern instead of a rain garden is space and need for water, right? So you can capture a lot more water in a smaller footprint with a cistern than you can with a rain garden. And right. So, and there are several types of systems that you can have. You can have a passive cistern where it captures the water and then just slowly drips it out, or you can have a pressurized system where your cistern captures the water and then goes through a pump and pumps it out with more force. Yeah. And so, like I said, you've got this PDF. Take a look at it. You've also got my email there. So if you have questions, you're welcome to. Let me just touch real quick on maintenance. Anything you build that you want to continue to function the way you intended requires maintenance. And it will require maintenance forever. So it's important to try and build something so it needs the least maintenance possible, but also it will always need maintenance. Okay, well, thank you for your time, and I hope this was useful. Again, you can always email me if there's no time for the questions now, or if you just have them later. I
Thanks.
give up.
We'll switch over to Lauren, and then at the end, if we have time, we can do a batch of questions.
All right, thank you, Staryn. I'm always fascinated by what I learned from you, and I think it's awesome that this group is getting to as well. I am switching over, and let's see. Can everybody see my screen?
Yes.
Okay.
Yes,
I
and
cannot
I'll
see
keep you
y'all now.
posted on questions.
Okay, thank you. I'm Lauren Zapone Maples. I'm the executive director of PEAS. We're Partners for Education, Agriculture, and Sustainability. And we are a nonprofit community partner that has been working with Austin Watershed Protection and AISD schools. This particular project at Reilly has been a really fun collaboration, and our team for sure has learned a lot as we have gone through these processes and learned more about the systems that have been set up at Reilly. And our role is outdoor education during the school day. So our educators go into classrooms and work directly with classroom teachers throughout the school year. We see 5 classes and we see them all year long. So over the years, we've worked with different grade levels at Reilly. This year, we're working with kindergarten and first grade students. Other years, we have worked with second and third grade. But what we have realized is that all that cool infrastructure that's doing all that good work for our ecosystem really is an opportunity for our kids. And really, our job as educators is to translate that knowledge from what Staryn and his team has put in to something that is not just interesting, but also exciting for kids. So we really want to get students hands-on in their outdoor spaces to learn more about the ecosystem that's right in the community around them. And that's what we've done over at Reilly. So I'm going to share a few of our projects that we've done in these spaces. As you've heard, the rain gardens are filled with plant life. So when we first got going on this collaboration, The rain gardens were brand new. We've been working in this space for 8 years now, so since the very beginning. And at the time the plants went in, it was also a very dry season in Austin, not like the spring. We've been very lucky. But so we really had to focus on having our students, and this was an opportunity for them to understand that even though we're planting native plants in the livelier rain areas, they still require watering in those critical first year periods. And so we got to involve our students a lot in that in the very beginning. Later on, as the spaces, the rain gardens got more established, we would help the students learn about which species were invasive or just not desirable maybe in the area. One thing we find on a lot of our school campuses is that the squirrels really love to replant pecan trees everywhere. And some of these spaces in our rain gardens were not ideal for that. So helping students identify the invasive species, talk to them about what it means to be invasive. Sometimes it's just they're in the wrong place for the purpose we want. Other times they can actually threaten a plant community. And so we really want to teach them about biodiversity and what those threats to biodiversity could be. And then over time, and especially in the beginning, there were opportunities for us to do some more replanting with the kids when things in certain areas weren't taking off, maybe because they didn't get enough water, or in the space that he showed that was primarily a sod area, we realized there was also a really great opportunity to seed that area with native wildflowers. And so over the years, we've had the kids seed and reseed different areas that will help increase the biodiversity of their campus. And seeding is always a fun activity with the kids. And, we get to talk about everything as, from native plants to the life cycles of the plants to the life cycles of the species that use those plants as hosts. And so each of these activities is a really major opportunity for our kids to engage and understand more about what these cool spaces that are very unique to their campuses, what they're providing for the greater community. Another activity that is fun for our students is cleaning the debris from the rain garden and retention area entry points, to teach them more about that flow across the land when we're talking about our watershed and we're talking about that light or the flow of the water drop. Then they can see how sometimes those drops will get, stuck in areas. They might not be, we don't want them in the parking lot because we'd rather have them in the soil where they can infiltrate and stay in the land. And so by walking students through these processes of cleaning both the entry points and exit points of the rain garden, they can get a better idea of how the water is flowing across their school campus. And then another fun thing is looking at the water quality. Reilly Elementary is right up, it abuts Waller Creek, which is the creek behind me in this picture in my background here. And in the beginning, before the school district fenced in all the schools, we were able to at least once a year, sometimes twice a year, take the classes down to the creek to collect their own water samples. And then they would study and see the macroinvertebrates in the water. They could determine based on which macroinvertebrates were present or not present, whether, what the quality of the water was. And that was always fun for students. We now, there's still an access point, but it's just has become more overgrown because there has not been as much passage back to the creek. But we now have been, over the past few years, collecting the water samples ourselves and bringing them to the students so they can still experience the activity. It's just a little more challenging to get back into the space. And then the other piece of this is learning from the systems and the operations of the system. So talking to the students about, again, how that water droplet is flowing and what's preventing it from getting to where it needs to be. If we want water in the cisterns, so some of the cisterns also, we share with the students, some of the cisterns are intentionally leaky. And so when they fill up, they slowly over the next 48 hours drain into the ground. And that's where we want the water, in the ground. And some of the cisterns will hold on to the water and can be used for other purposes like watering. They used to have a vegetable garden. They could redirect that water and use it for purposes of watering their other native plants in their courtyard and things like that. But the kids also start to understand, as Staryn was mentioning, that everything needs to be maintained, and the students can become supporters and helpers. The teachers can become supporters and helpers to help us understand when issues are arising. A big one for these gutters and the cisterns, or the connection between the gutter and the cistern, is that they'll get clogged with leaves. So helping the students realize if they see a gutter overflowing and it's not at the point where it's going to the downspout, but there might be a leaf clog, they can report it to their teachers, who can report it to us, and then we help them report those issues to the front office in the district. Another activity that we do with the kids, or did a lot more in the beginning, now that the areas, the gardens, are pretty well established, there's not nearly as much work. But in the beginning, the berms, as Staryn was mentioned, sometimes they erode. Some of it was from the rain itself, and some of it was from students just being in the area and walking through the areas. But over time, when we'd have our service project days, we'd have the students help to rebuild the berms and help us understand where there are areas where they may need to be reinforced. And that is always, anytime the kids get to get in the dirt and build with it, they really appreciate it. So that's an activity that they have really enjoyed. And now that the rain gardens are much more established, it's a less frequent part of our service projects. And another big activity that we like to do with students is conducting what we consider a waste audit, to look where there's litter on the campus and understand how it's getting there. Some of it, of course, is not water related, but where there are areas that we know the debris is moving, we definitely use that as an opportunity to share with the students and talk to them about where it's going to go from the campus. Like, it's not just going to stay there. It's going to end up somewhere. Where does it end up? Help them identify the storm drains, as Staryn pointed out in one of his early slides, that anything that's going to go into one of these storm drains here is going to go directly to the creek. So watching how the water may move the litter and waste to areas where then it will get picked up, it will get picked up and go into those drains, and help them just collect that and get it out of the way. It's a really big awareness builder for them. And then one of our last, each semester, we do a celebration lesson. And while we are reviewing what they've learned over the course of the semester, we also use this opportunity to highlight careers in nature, because we really think it's important that the kids not only understand that these are things that are happening in their communities, but also that there are careers that they might choose when they grow up to be a part of, to continue protecting our ecosystem. And so we have 3 different celebration lessons that we rotate at Reilly, and depending on the year, no students will get the 2 same, but they'll get 2 of 3 of these. And one is we highlight our watershed protector. Another is Staryn as an environmental scientist who is also working to from a more interdisciplinary aspect of protecting our water and working with the city to, support our ecosystem in Austin. And then an aquatic biologist or hydrologist is the other career that we like to highlight. As I said, we do find that there are reporting issues. So if you are with AISD or know someone, we have created a protocol with the district to help, because we as a third party in the city as an external resource to AISD cannot do the work ourselves if there are issues, but we have created a protocol to report. So each campus should have someone established that can be their lead contact that will take the needs of any infrastructure issues to the front office. The point person then can communicate it to the office staff and help them put in the work order. I think this is a big piece is to just get the language right in the work order. So having someone who knows about the systems to some degree of detail is helpful. It doesn't have to be the ins and outs, but knowing like the names of the infrastructure and locations to be able to clearly identify it. And then now there is the point person on the district facility side is Mandy Goldman in AISD. And then we, or the point of contact, will just let her know to be looking for those work orders that are coming through from whichever particular school it is. And then soon there will be a person in that position of irrigation and cisterns to help with some of those specific issues. But otherwise, Mandy can help put whoever is on the school campus in contact with the person that's going to be able to help with the issue. And that was the very quick and the quick and easy version of what we do. Open to any questions you guys may have.
Thanks, Lauren and Staryn. While we wait for questions to come in on the chat, real quick, I did put in the chat our evaluation. So if y'all wouldn't mind taking a moment to fill that out, then we can share with our wonderful presenters how they did. So thank you so much. And then I will say, if any of you want to learn more about what PEAS does, because I know Lauren had to go real fast, we just published their last webinar literally today on our YouTube. So if you go up, the latest video posted is all about PEAS. So you can learn more from there as well.
Renee,
And I will also,
go ahead.
I was just saying, I'll also share my slides with Sarah to share in an email.
Perfect. Thank you, Lauren.
Renee, is your son Matt? Yeah. All right. Cool. Yeah, it's been great working with him.
Yes, I was just saying in the chat, thank you, Lauren, for all of your work with youth, because it really does pay off, and it does help them appreciate nature, and I give all credit to all of his previous teachers for that, and hopefully myself a little bit too. But
I'm sure.
But all the teachers that helped get him out into nature.
That's wonderful to hear.
Mm-hmm.
Yeah, and my email is in the PDF. So it's, feel free to reach out to me if anybody has any questions or wants some help or guidance on something. I'm usually happy as soon as I've got the moment to respond, to help out with anything related to this or anything that I know. Information is to be shared.
Wonderful.
Same here.
Thanks y'all so much. We're in our last minute. Our next webinar is calling all outdoor and nature experts. ECE needs your help. So register today for that. Again, thank you so much for doing the session. And if y'all have not already heard, it is summit season. So our conference is December 9th through 11th in San Antonio this year, and we are currently accepting proposals for sessions. So if any of you have a session idea, please go ahead and send those in. The link is on our website. So thank you so much, everyone.
Thank you. Bye-bye.
Thank you. Y'all have a great day. Bye.